Good morning, sir. My name is N. Devi. I am from ECE. Today, I am going to tell you about Ohm's law and its limitations. In this Ohm's law and its limitation, we discuss first Ohm's law, and the limitations are temperature dependency, nonlinear devices, high frequency effects, power dissipation, non-ohmic materials, electric transients, and shortcomings in complex circuit, and finally we go through the conclusion. First we discuss about Ohm's law. Ohm's law at constant temperature and some physical conditions. The potential difference at the two ends of this conductor is proportional to the current flowing in that conductor is known as Ohm's law. Mathematically, Ohm's law represented as V is equals to IR. Here V represents the potential difference of two ends of the conductor, and I represent current flowing in the conductor. R is the constant, and we go through the limitations. And the first limitation is temperature dependency. In Ohm's law assumes that the resistance of a conductor is a constant at given temperature. The resistance of most materials changes with temperature. As temperature increases, the resistance of conductor typically increases, leading to deviations from Ohm's law. And we can go through the second limitations of Ohm's law, which is nothing but non-linear devices. Ohm's law is only applicable to linear devices such as resistors with a constant resistance. Non-linear devices such as diodes and transistors do not follow Ohm's law. These devices have varying resistance with change in voltage or current, making Ohm's law invalid for their analysis. And the third limitation of Ohm's law is high frequency effects. At high frequencies, the behavior of circuits may deviate from Ohm's law. Inductance and capacitance become significant, and impedance rather than resistance play a crucial role. And Ohm's law does not account for these frequency dependent effects, limiting its usefulness in high frequency applications. And the fourth limitation of Ohm's law is power dissipation. Ohm's law focuses on the relationship between current, voltage and resistance, but it does not consider power dissipation. Power dissipation is a crucial in many practical applications, particularly when dealing with the resistive elements like heating elements. Ohm's law alone cannot provide insights into power dissipation characteristics of a circuit. And we can go through the limitation of 5, nothing but non-ohmic materials of Ohm's law. And Ohm's law assumes the linear of resistance, but some materials exhibit non-ohmic behavior. Non-ohmic materials such as semiconductors have a resistance that varies with applied voltage or current. Ohm's law fails to accurately describe the behavior of circuits containing non-ohmic materials. And we can go through the limitation 6 of Ohm's law, which is electrical transients. Ohm's law is not applicable during transient conditions such as when a circuit is switching on or off. Transient can cause sudden changes in voltage and current, leading to deviations from Ohm's law. During these transient periods, additional circuit analysis methods are required to understand behavior accurately. And the final limitation is shortcomings in the complex circuits, and this is the 7th Ohm's law limitation. Ohm's law simplifies that analysis of simple circuit with only few components. In complex circuits within multiple interconnected components, Ohm's law may not provide sufficient information further, and the interaction between various elements and the presence of reactive components necessitate for more advanced techniques for accurate analysis. And finally, we conclude that Ohm's law is a foundational principle in electrical engineering, describing the relation between current, voltage and resistance. However, it has certain limitations that must be considered when analyzing circuits. Understanding these limitations allow engineers to employ additional tools and techniques to accurately analyze and design complex circuits. Thank you, sir.